Okay. We have f of x equals to the sine of x plus the cosine of x. Right?
Yes.
Okay, so f prime of x. What is it we're looking for? Just finding the points of inflection. Okay, so what is the derivative of this? Cosine of x minus the sine of x, right? So it winds up being f prime of x, f double prime of x, equals to negative sine of x, negative cosine of x, or we could say the negative of the sine of x plus cosine of x, right? And we want to know where is that equal to 0. Now, to see where that is equal to 0, I can pull. I'll tell you what, it's not easier for me to have the negative sine of x, negative cosine of x there. So I'm going to change that up just a little bit. I'm going to rework it like this, and I'm going to leave that as the negative sine of x equals to cosine of x. So let's ignore this one. Set this equal to 0. Okay, so the negative sine of x equals to cosine of x. In other words, where will sine and cosine equal to each other but have opposite sides? And we're talking about this interval from 0 to 2 pi. Well, first off, where does sine and cosine equal to each other? In the first quadrant. At 45 degrees, which is what in terms of radians? What? Pi over 4. Okay. And they equal to each other in the first quadrant. What other quadrant do sine and cosine equal to each other?
3.
Quadrant 3. Why do they equal to each other in quadrant 3?
Because you get 180, so that's like 1 pi, and 1 pi.
Which would be 5 pi over 4.
That one.
All right, but why? Why do they equal to each other there?
I forgot the other negative.
Because they're both negative there, yeah. Yeah. Remember, all are positive in the first quadrant, tangent's positive in the third quadrant, meaning sine and cosine are both negative. So they're not equal to each other in the in the second and fourth quadrant, they're not equal to each other. Why not? All right, what's positive in the second quadrant? Sine, so what's negative in the second quadrant? That's cosine. And then what's positive in the fourth quadrant? So what's negative in the fourth quadrant? Sine. All right, are y'all with me? So sine and cosine equal to each other at pi over 4 and at 5 pi over 4. So where do they equal to their opposites? Well, what would be pi over 4 in the second quadrant? Well, that would actually be the sine or the cosine, but what would be the angle? It's going to be 45 degrees. What is 45 degrees in the... Okay, 135, and how do you change that to radians? Pi over 180? Okay. 45 goes into both. So we get 3 pi over 4. Now, this is the way I tend to memorize it. The 45 degrees I associate with 1/4. Okay? So, and from here all the way around to here is pi. So from here to here would be 3/4 of the way. So it's 3/4 of pi, or 3 pi over 4. That's the way I remember it, and I don't have to do that pi over 180 every time. But
what's the word for like the way the angles that are like, I guess not equal, but like pi over 4 is like 3 over 4 pi. Trying to think of that word, like the way we were always taught to do is just like subtract it, like
yeah.
Pi minus pi over 4 to get 3 pi over 4.
Yeah. Supplementary? Well, they would be supplementary to each other, but I don't think that's what you're looking for. Can anyone help me out here? Say what you're saying again.
There's like some type of angles that are together. It wasn't complementary or supplementary, but like they work the same way. Like you go to much fewer in the fourth quadrant, you subtract it, and you get like pi over 4 times.
Yeah, 2 pi minus pi over 4. It's 7 pi over 4, but all I can think of is that they share the same reference angle, but I don't know that.
That might have been what it was.
I don't remember a term for it. But anyway, the other one is 7 pi over 4 because of what you said. 2 pi minus pi over 4 is 7 pi over 4. I tend to think of it more as, when I'm in the fourth quadrant right here, I tend to think of it more as being, okay, I'm going pi and then plus another 3/4 pi, and pi plus 3/4 would be 7/4. So that's how I tend to think of it, but whatever works for you is fine there. So that's what we're looking at there. Now, let's look at 35. Again, this is on page 195. I wonder if this video is going to go viral. Let's see what we got here. We've got 2 times the sine of x.
Are you recording you or did you pay it?
Well, I step back every once in a while. See, right now I'm seeing. It's good stuff. But now I'm not seeing.
You should get the,
Yeah, it's, it'll be,
you should get the dance of the potion roll video.
but I might not. Okay, so anyway, what is the derivative of 2 sine? 2 cosine. And then plus, be careful,
That's
2 cosine of 2x. Because remember, you have to take the derivative of the angle also. Alright, and then let's take the derivative of this. Oh, sure. F double prime of x is equal to negative 2 sine x minus 4 sine of 2x. Okay? So again, let's set those equal to each other. This is going to be 4 sine of 2x equals negative 2 sine of x, right? Divide out by negative 2, so we get negative 2 sine of 2x equals sine of x. So where is negative 2 sine of 2x equal to the sine of x? It'd definitely be 0 and 180, or 0 and pi. I'm thinking that's going to be the only places. 0 and pi.
Back to both is 1.823 and 4.46. I don't know what that is in terms of
Say that again.
1.823 and 4.46.
Okay, so they were turning this into a calculator problem. 1 point what? 4?
No, 4.46.
4? 4.4 what?
6.
6. Okay. Let's look at that in the calculator. Get your calculators out. I was trying to do this without one. And all the other answers, do they? Well, that was pretty much the only. Now, going back to this problem here, you have, when we first did it, we should have had it set equal to 0. But y'all didn't remind me to, so it's your fault. Thank you for, and I was mainly blaming Gerard on that.
I'm not apologizing.
That's not wanting it. All right, let's see what we got here. Let's go to y. Well, make sure you're in radian mode first, because if you're not in radian mode, then it's not going to work right. So we're going to go with y equals, and I'm going to do negative 2 sine of x minus 4 sine of 2x. All right, and I'm going to graph that. Change my window.
Negative 2 sine of x minus 4 sine of 2x.
Yeah. Okay. They left off 0, but 0 should have been one of the answers. Or did they leave out 0 in the back of the book?
Well, they left out, yeah, they did leave off 0 to go to
Okay.
they just started concavity.
All right. So let's see what we have here. Now remember what I've graphed here is the second derivative, and I want to see where that's equal to 0. So what I'm going to do is I'm going to go to second calculate, and 2 is my 0. So I'm going to scroll over here. Well, past it, and I'm gonna pick a left bound. So I'm just gonna push enter. Can y'all see the cursor up there? Is that's oh, y'all can't even see that screen. Is that better? Close to better. All right. Do you see how I have it blinking
Yes.
just a little bit right there? Okay.
Close to 1.
Yeah. All right, I'm going to push enter there because it's asked for the left bound. And then I'm going to scroll just a little bit to the right of where they cross, and I'm going to push enter. I'm going to push enter again. And it's going to tell me 1.823. So that's one of my points. Are y'all getting that? Okay. Let's start back over. All right. Have y'all got the equation in? Negative 2 sine x minus 4 times the sine of 2x. Okay. What you do is go to second calc, and number 2 is 0. When it says you're looking for a 0, what you're doing is you're actually looking for where the value crosses the x-axis. Okay? So the first thing it asks for is a left bound. So I'm going to push enter here just to the left of it. And then I'm going to scroll and go just barely to the right of where it crosses, and I'm going to push enter again. You're scrolling by using these 2 keys here. And then it says guess, but just ignore the guess and push enter again. Oh, it says error. All right, you may kick you out. All right. Here, I'm going to scroll. Just right here. See, that's going to be just to the left of that intersection. Right? I'm going to push enter, and I'm going to scroll just to the right of it. Push enter, push enter. Yeah. All right, are you getting it?
No.
Okay. If someone's getting it, help.
Somebody know.
All right.
Do you need help?
So we're going to go to the graph. Just like that. So we're going to go second calculate, and that's my 0. So that's going to be my intersection point. So I'm going to push 2. Now, I'm just barely to the left of where it crosses the y-axis. I mean x-axis, I'm sorry. So I'm going to push enter. And I'm going to scroll right here. And I'm going to push enter again. No, that's not the soccer.
Yeah.
Oh, you use a left one? Okay. Did you do the left one? Okay, so put enter and then the left one.
All right, guys. So, anybody else need? Okay, you did. All right. Did you see what to do? Okay.